In the last couple videos, I've been trying to emphasize as much as possible that anytime we're considering a limit, you need to pick values that are both greater than as well as less than the destination number, whatever x happens to be approaching. What I'd like to do is consider the following function. It's referred to as the Heaviside step function. The Heaviside step function gets used quite a bit in computers. Reason being, it is defined piecewise, and the only two values that it can be equal to are 0 and 1. The Heaviside step function represents something changing from off to on. So 0 when we are less than, and 1 when we are greater than or equal to. So if something is off for an extended period of time and then is turned on, the Heaviside step function is how we model that behavior over the course of time. What I'd like to do is consider the limit as t approaches 0 of the Heaviside step function. Now, if we're going to do the things that we've done in previous videos, that means that I will need to consider some values that are less than 0, and some values that are greater than 0. However, this function is constant on both of those intervals. So when we're plugging in values of t that are less than 0, the Heaviside step function is going to let us know this function is currently off and give us an output of 0. Whereas if we're approaching from the positive side and we're inputting positive values of t, we're going to wind up seeing values where the function is on or equal to 1. These two functions are not approaching the same value as we get closer and closer to t equals 0. So in this sense, we would say that the limit does not exist. However, if we take a look at the individual values that are simply less than 0 or simply greater than 0, then we get that there is a limit, it does exist. This is the idea behind one-sided limits. So the two ways that we would represent this would be the limit as x approaches a from the left-hand side of f of x is equal to L. We refer to this as a left-hand limit. Where we are selecting values of x that are only less than the value a. Whereas over here we have the idea of the limit as x approaches a from the right-hand side of f of x is equal to L. This is referred to as a right-hand limit. And we would be selecting values that are only greater than a. So in the context of the Heaviside step function, we would be saying that the limit as t approaches 0 from the left of the Heaviside step function, from the left means using only values of t that are less than 0, we see a nice consistent 0 here. Whereas when we approach from the right-hand side, limit as t approaches 0 from the right-hand side of the Heaviside step function, we'd be talking about the values of t that are only greater than 0. And we see that the value of that limit is equal to 1. So whereas the one-sided limits both exist, we refer to this as now the two-sided limit. The two-sided limit does not exist if these two values are not the same. So put in more general terms, what we're saying is that if the limit as x approaches a from the left of f of x is not equal to the limit as x approaches a from the right of f of x, then the limit as x approaches a of f of x does not exist. If the left-hand limit and the right-hand limit approach two different values, then the two-sided limit does not exist. Typically, you'll only see this behavior in piecewise defined functions, but there are some exceptions.